Hello everyone, my name is Shahin Atakishiyev and I am a PhD student in computing science at the University of Alberta. This presentation is based on my current PhD research and the title of the presentation is an explainable reinforcement learning-based framework for compliance testing of autonomous vehicles. In this research, I am working with professors Rende Gobel, Hengshui Yao, and Tony Q. This is a brief agenda of the presentation. I will talk about the need for explainable AI, also known as XAI. Then I will shed light on main components of safe and regulated autonomous driving. And finally, I will conclude the presentation by proposed autonomous driving framework and summary. So why do we need explainable AI? So we know that majority of current AI systems are black box. It means that we can see the end results that AI systems produce, but we don't know how these results are actually produced. That's why the growing concern for a right to an explanation requires that AI systems should be transparent to ensure clarity and reliability in their application domain, such as in autonomous driving, medicine, and law. So XAI in autonomous driving intends to explain the decisions arrived by autonomous machines to provide safety, transparency, and reliability in accordance with the requirements of regulatory compliance. Based on our analysis, we suggest that we need at least three principal components to achieve safe and regulated autonomous driving. First of all, the capture, transformation, and the processing of real-world data to continuously learn control models. Then, a mechanism that transforms multiple sensor inputs into a context to determine the most appropriate actions in real time for autonomous vehicles. And finally, a learning system framework that continually adjusts and enhances while ensuring the best possible safe operation in any scenario for an autonomous machine. So we propose an autonomous driving framework which has three key components. First of all, multiple world models which are learned from the data captured by sensors. Then question generation, which is obtained by querying the world models. Finally, a method of evaluating the answers to the questions in real time. So what is a world model? Well, a world model is an environment that an autonomous vehicle interacts with and process the relevant data from. Basically, we can say that the world model provides a data hub to an autonomous vehicle, which will be used for its real-time decision-making in any situation. Question generation. Why is it important and how are these questions generated and leveraged? When driving, it's very natural that we think about questions like, will the front car brake? Will the car in the front right of me cut to my lane, and so on? These questions come actually very naturally, and thinking about and answering these questions prepare us for a good drive in the front. So in our framework, we try to use multiple data sources and try to turn these data sources into actionable situational questions, whereas the obtained answers will provide the context to prioritize the choice of actions. The learning architecture is based on an ensemble of reinforcement learning processes, each of which compete with each other to produce best answers. This mechanism is also called a prediction as knowledge. Basically, the prediction as knowledge representations try to use large collection of predictions to model their environment. And here an agent regularly expects its sensation from the environment and makes a lot of predictions regarding the dynamics of that environment. And how are decisions made? We use a reinforcement learning approach for this purpose. So reinforcement learning is an AI approach which allows software agents to take optimal actions in an environment to maximize its performance. This performance is often measured in terms of notion of cumulative reward. Reinforcement learning is actually a very powerful computational architecture that is used for real-time decision-making of a lot of autonomous systems. So if we give a scheme of reinforcement learning agent, so we see that we have an agent. Here an agent takes an action A in its environment and it gets to a state S. and when executing each action, it receives a reward, and the agent tries to maximize its reward in each action. And this is the schema of the entire explainable reinforcement learning-based framework for autonomous driving. First of all, we have data sources, and we try to convert this data into question representations. Then we use prediction as knowledge approach to answer questions. Finally, in the last stage, we have several oral processes which compete with each other and try to answer the questions best. And the ones that answer the questions best, they get to and execute an action. So based on this framework, we expect that autonomous vehicles will be much safer than the current state of the art. In addition, they will have explainable decisions in critical situations. And finally, by doing so, they will also comply with the requirements of law enforcement. This is the end of the presentation. Thank you very much for your attention.